Hello, everyone. Welcome to a forecast discussion. I'm going to be going over about today's severe weather here in Minnesota. The SPC, or Storm Prediction Center, has put out a moderate risk for the potential for an outbreak of supercellular storms that are going to be erupting here later this afternoon. Actually, if you see currently on the radar here, we have a cluster of thunderstorms that have already begun developing here across western Minnesota, western kind of southwestern Minnesota here. Right here you see a few severe storms. Actually, a few moments ago, this storm used to be tornadic. It used to have a tornado warning on it, but now it has expired, mainly due to there isn't really too much evidence of any circulation in it anymore. So but we'll definitely want to continue to monitor these storms as we head into later this evening, as these storms will intercept more wind shear and instability as they continue to move eastward. And as they continue to move eastward, we want to continue to keep watching these cells as well, especially as we continue to again go into the evening hours, as tornado probabilities will definitely start to be increasing with time here, as we continue to go into the future. Today we're just going to be going over in this little kind of short, it's not going to be too long, just a little discussion here that we're just going to be going over really what's going on with this environment today, why are we having severe weather today, and what are the main threats that will be going on here across the area here today. This moderate risk actually keeps every time Storm Prediction Center updates it. It's not every update, but it's every couple. They'll do updates, but it won't be every update. It's kind of like every other update. They'll keep expanding the moderate risk, which I can pull it up here in a second. But general idea, it kind of includes this fairly large area. I know that's kind of it's kind of a poor drawing or example of it. Here I can pull it up real quick. Let me just do that real quick. Okay, so definitely this is a storm system that we really want to continue to watch here as we head in to the evening hours here. Here it is. All right, so this is the moderate risk here for today that's in place across. Let's see, can you see this on the screen? I'm gonna try to see if we can put this on the screen. Okay, I think that's a little bit better. All right, this is the best I can get so far. Okay, so this is the moderate risk right here. It extends into areas including Minneapolis, St. Paul, Rochester, Minnesota, Bloomington, Minnesota, and Plymouth, Minnesota. Just to get a general idea of where it's located. The Storm Prediction Center has put out a 15% chance of tornado probabilities. This is basically anywhere in here, especially in the hatched risk. It basically mentions that it is an area where it's a 10% or greater chance of probabilities of an EF2 tornado, EF2 to EF5 tornadoes within a 25 miles point. Now, we are not expecting EF5 tornadoes, just to be clear. Because the environment is definitely not set up for that, which I'm very glad for, because I live in Minnesota, so I don't want to get destroyed by EF5 tornadoes. But anyway, the idea of strength for these storms today will probably be around EF2 strength, which, if you're wondering how strong an EF2 is, it's around 111 to, I think it was like 135 miles per hour winds or something like that. Definitely is something that can cause damage, especially in I guess, more urban areas. And yeah, because as especially when these storms start heading into, if you see right here, as these storms continue to progress eastward into the more southern metro to even metro regions here, um, you definitely want to continue to keep an eye on these storms, as you want to be looking for those little couplets here. I guess a quick little explanation of how we find that type of thing. So, uh, so to find uh, rotation in a storm, you usually use something called super resolution velocity, which is basically it's a product that helps kind of show like the direction of where winds are going in storms. So it's kind of a basic explanation. But basically, what we're looking at here is the green. The green indicates winds heading toward the radar, and then the red means winds going away from the radar. So essentially, what you're seeing here is this is rotation aloft. So if you're wondering how, just to get an idea, this rotation is occurring about 3.6, 3.7 thousand feet, or sorry, 3,700 feet, I believe, is what that is. So that's a good. Um, it's still a good height. So we don't actually know too much about at the surface. So that's why it always helps to have like storm spotters and skywarn, I meant storm chasers out on the field to be able to kind of get an idea what's actually happening at the surface. So that's why sometimes you'll get, oh, it's radar indicated, but the thing is, we don't really know if there's actually tornado on the ground. However, there will be times where we actually be seeing, I'm just kind of giving an example of, if you ever have heard radar confirmed tornadoes, those occur when you have very strong wind gradients, or I guess you could say, on here. So you have very strong, like very bright greens. It can be like very light greens to kind of like a very bright blue color that can occur with the winds coming toward the radar. And then for the winds going away the radar, you can get very strong, kind of like reds to kind of almost like a pinkish color for that. So that's kind of a general thing you want to be looking for. It's just those little kind of couplets almost. Some storms you'll see some better indications of them, these couplets. Kind of can see if you bring out reflectivity, you can sort of see a little bit of, if you go back here, if you few frames, you can sort of see the supercell resemblance here with the kind of a classic little hook here with you got your main, you got your inflow right here, and then I'm trying to remember, I think you have like your I think you're a little bit outflow maybe. I would have to look at the diagram of a supercell again, but I know for sure that you got your inflow here, and then when you got your inflow mixing with some of the storm dynamics, you'll definitely get that little couplet that develops, and sometimes you'll get tornadoes that will spin up here. And when you got a very strong occurrence of this type of thing, that's when you'll get radar confirmed tornadoes. One last thing I want to mention too, when looking for tornadoes, you can also look at the correlation coefficient. This is basically a product of radar that kind of helps the radar kind of tell between things that are precipitation rather than things that are non-precipitation. So, for instance, when you're looking for something like a tornado, like tornado debris, you'll get like these kind of highlighted, deepened kind of colors. Sort of, kind of looks something like this kind of color right here. But you would get that type of indication, like let's just say if it was like right here, if you had this type of thing, this type of coloring right in like this circle here in this part of the storm, that would be an indication that you have debris being lofted or sorry, it would be debris is being lofted kind of above like several hundred, or not 100,000. It can be 100,000, but it can be lofted quite high, and radar can actually pick that up, and you'll get these little like almost like blips of coloring here that you'll get from those, and that's indication that you have debris being lofted quite high. So yeah, that's definitely something you definitely do not want when it comes to these types of storms. Now, will we see this type of indications with this system here? I kind of doubt it, because I mean, even though we are in a moderate risk, it's not really, today's not really conductable for those type of tornadoes. Those type of tornadoes would be considered violent. Now, today's environment is suggested for strong tornadoes, which includes I think it was EF2 to 3s are considered strong tornadoes, and then anything above 2 to 3, like 4s and 5s, those are typically classified as violent tornadoes, which is not on the table here for today's weather. So yeah, so now let's dive into the dynamics here. I'm trying to find this. Yep, let's dive into the dynamics here. We're going to be taking a look at a mesoanalysis here of the storm structure and environment that is in. So I'm going to give you a little I'm going to kind of show you kind of meteorology 101, how you kind of observe the ideal kind of area kind of thing, I guess. Anyway, so what do we have here when looking at surface analysis? So we got a fairly large low pressure system right here, and then you can actually kind of pick out a little bit of the cold front by you see a little bit of these pressure tongues here, and then also if you were to look at surface observations and kind of look at the temperatures, we got 70, 60, 80. It might not be very powerful. Or not very of a contrast between the two temperatures, but typically when if you're trying to pinpoint a cold front, you typically want to find a line where there's a contrast between warmer temperatures and cooler temperatures. So for instance, if there was a cold front, like let's just say right here, that was a little bit more powerful of one, you would have typically your warmer side here, and it would definitely be, you could pick out a cooler side over here. But in this case, this might be more of a above ground or kind of a loft cold front here that we're kind of dealing with. So that's probably, yeah, most likely it's more of kind of like a, maybe you would want to say a stacked front type thing, where more of the kind of forcing is doing a loft or something like that. But anyway, so yeah, we got a cold front. We got our let's go back to here. You got your cold front right here, even though it's not pinpointed on here, but there is definitely one here, as I guess hence the convection that's already going on with the storms. And then we got your warm front, which will be right around here. So identifying these type of things are very valuable when trying to determine where storms will initiate from and stuff like that. So we definitely want to, they're very helpful to be able to find. We're going to actually head over to Weather Prediction Center, just kind of help get you an idea. So this is what it actually looks like when you put it all together. You can see you got that little pressure tongue right there. And you even see here, see, do they have, okay, they cancels it out. Okay, so you kind of see here, what I was mentioning, there's not too much of a contrast. You see there's 80s, and then a little bit of a 70 drop here, But I mean, it's still warm on the other side. You're not gonna experience like, oh, it's gonna be 80 here, and then all of a sudden it's gonna drop 30 some degrees. If that's the case, we would have extremely robust storms that would go on, and it would just be insane if that was the case. But no, that is not the case. This is more somewhat surface interaction with slash mainly elevated forcing that is causing these things. So anyway, yeah, you got your cold front here, you got your warm front there. And then another thing you want to look at when you're looking at storm environments is your instability. Let it load. My computer's a little slow right now. Your instability is the thing that you want to be looking at when forecasting for storms here, because this is your energy that you'll be needing for your storms to be able to kind of blow up, I guess you could say. So that's kind of what these storms are interacting with right now. You got around 4,000 some joules per kilogram, or CAPE. If you're wondering what CAPE stands for, it's convective available potential energy, and just kind of the general idea what it is. It's just the energy needed for supercells to be able to develop, or supercells are thunderstorms, really just storms in general to be able to develop here. And yeah, so just pinpointing just the greatest area of instability is definitely helpful when trying to determine if storms are going to be producing either like hail or something like that. So yeah, and in this environment we got moderate to pretty good instability here. So what we're kind of looking for, using what we also call shear, which is basically winds changing with height, we want to continue to watch these storms. Let me put this over here. Continue to watch these storms here as they become more robust with time as they continue to progress eastward. But what we continue to look for is once they get probably kind of in this area, yeah, kind of this area, there's going to be kind of almost enhanced wind shear that will be in this area. So once they get into kind of more of this direction, let's move into more of the metro region, we're definitely going to be seeing more of that. The storms will become more, I guess you could say, sheared and a little bit more well organized, supporting the potentials for strong tornadoes potentially, or even just large hail. It's just really going to help kind of separate what we call the updraft from the downdraft, making the storms more robust and stronger and stuff like that. So let's bring over our thing again. And so we can actually check off a few things real quick. So when you're weather forecasting too, you want to be looking at the upper air dynamics. So 500 millibar analysis. This is, I guess this is really what you want to be looking for when forecasting for severe weather. So for this setup, we got a fairly large trough here. That's actually positively tilted trough, but this is actually this whole thing right here. This is not what we're going to be watching. It's the features associated with this jet streak that's going to be moving in and has been moving in here today. And there is a associated with this jet streak is you got your cold front, which will be causing and have caused those storms to develop. And so we see here, it's kind of hard to see. Let's see, 50, 60, 70. We got around 75 knots of shear, which is for severe weather forecasting. That's really good for elevated shear. Also, if you're wondering, 500 millibar level is basically kind of like the middle point of the atmosphere. So it's a good area to start off with when you're trying to forecast for thunderstorms and stuff like that. So you're gonna have, yeah, we got like around 70 to 75 knots of shear, which is, yeah, definitely really good for fast moving and well sheared storms. We can even go up another level, and we can look for areas of divergence, which is another topic, but it's usually divergence. I guess a short example of it is you have winds basically spreading aloft. Here, I can try to draw it out for you. So imagine here you got, let's just say, like a little trough right here, I guess, or even trying to draw the jet streak or whatever. But when you have divergence aloft, it basically means, let me redo this real quick. So when you have divergence, it means winds splitting aloft. So you got your, I believe they're called isopleths. Um, so basically, you got these lines here, and um, and so when you have divergence aloft, it means winds, again, I think I mentioned this several times now, but winds splitting or kind of um, spreading apart. So when you have winds spread apart from each other, it leaves this gap or void in the middle right here. And because thermodynamics at the surface and just in general doesn't like that, this gap is replaced by surface instability, or I guess rising air. That's what I meant. And that fills in that gap right there, and thunderstorms then erupt, and there goes your severe storm that develops. So yeah, just a quick little explanation of what that means. So just essentially wind spreading aloft, providing just a void, a gap in between, and so you get those more supercellular type characteristics with these. So anyway, this is your 300 millibar level. So this is definitely a few more. It's definitely really high. If you're wondering, I can try to see if I can pull it up here or try to find something of how high these levels are. I can do that real quick. But another thing we can look at too when looking at this is, just basically looking at all levels. So 300, 500, and then 700 if you're, this is trying to determine, it can be helpful for determining cap strength, which I guess we'll get to that in a second, more on what that is. But basically, this can help with a capping inversion, which again I'll get into in a second. And then we can go down a little bit lower to the 850 millibar analysis here. And this is where you can find your moisture transport. Your 850 millibar level is where you'll find your low level winds, and you'll also find your, again, moisture transport. So this is the main thing that brings up all your moisture for severe and just regular thunderstorms in general, development, and it's definitely helpful when looking at all these levels, including, again, the 850 millibar level. It's very helpful. And then 925 is practically the same thing. It's just a lower altitude to kind of get more of a closer to the surface, but not actually at the surface kind of analysis, trying to just get an idea of moisture and stuff like that. So, so let's head to the Storm Prediction Center real quick again. And also they did just recently, 45 minutes ago, they just put out a new tornado watch, which includes kind of just Twin Cities, a little bit of, I think you would call that a western Wisconsin, and a little bit of farther northern of the Twin Cities area. Main threats with this watch includes few tornadoes, a couple intense likely, and widespread hail, with the additional of scattered very large hail up to 3 inches in diameter likely, which, if you're curious of how big that is, that's around like baseball size hail. It's pretty crazy of how intense that or big those things really get. And then you also get your another risk of damaging winds with up to 75 miles per hour possible. So yeah. Anyway, let's head back to here, and I'm gonna actually show you another thing that we use a lot. This is a sounding, and they actually National Weather Service for Minnesota, or Chanhassen, has actually just released the weather balloon not too long ago, 19Z. So yeah, so this will give you, if you're wondering what this actually will give you a 2D representation of looking at the atmosphere with height, and it helps identify areas of instability and capping that can go on, which this is what a capping is. So a capping inversion or temperature inversion is an inversion in the upper atmosphere that basically prohibits any rising air particles or just rising air in general from, I guess, passing through this and breaking it and basically causing stuff to develop like thunderstorms or something like that. So when you have this type of inversion right here, especially during this time of day, it's really good to have that because it allows instability to build and stuff like that, allowing for greater potential when it releases, when it releases when that cold front that's triggering these storms over here. When it releases, that's when you'll get a lot of instability built up, and a lot of all that energy will be released, and it's just be a pretty crazy explosive show for that. So, and then another thing you want to look at to determine tornadic probabilities is your photographs. So the red right here is the indication is actually mapped with this photograph. So red is right here, green is right here. So the ideal thing is looking at curvature in the storm here, and that will help kind of get you an understanding of winds rotating, or I guess turning with height is kind of what you're getting at here. But anyway, I've been getting off track. I actually was supposed to do a forecast discussion, so let's do that right now. All right. My apologies. All right, so forecast discussion. Here we go. So you got your jet streak that's moving in here. That will be moving into a very unstable air mass. Let's get to the 20Z. Here, this will be easier to see now. So this is our air mass. This is our energy right here that I mentioned a little bit ago. This is your CAPE. So higher values means more instability. And so right now, this is kind of a general idea of what's going on right now. So we got in Twin Cities area, we got like 1,000 or so. But as we continue to press forward into the next couple hours, it will continue to move into the metro region by, let's see, it's 4 o'clock now. Let's see, probably around 5 to 6 p.m. this evening. And if you notice these big, almost like gaps in here, if you're wondering what those are, that's actually an indication that storms are present there and actually are taking advantage and actually eating up all this instability right here. So actually, basically these are just a presence of indication that storms are ongoing, and they are pretty, they're just wanting to eat all that stuff up. So yeah, we got a very unstable air mass out here. Um, we can actually take a look at our shear for this environment. So definitely can see that we got a good, 50, 60, even, some areas 70 knots of winds here that are being they're basically indication that we got some good I can't think right now. We got some good shear rate in this area. So if you popped out a sounding, you'll get this little box here, which it can be a somewhat of a help. It kind of just give you an idea of what type of sounding it is, but this just means PDS tornado, so particularly dangerous situation tornado is basically what it stands for. But we are not expecting this type of tornado. Tornadoes include the ones that cause debris and stuff like that to occur. So yeah, definitely. This is not really expected with the storms here tonight, but you definitely get these type of things that pop up when you got a lot of stuff going on with the thermodynamics of the environment. But when looking at the sounding here, we can actually see you got very strong surface, the 6 kilometer wind shear, which is around 64 knots, and surface 8 kilometer around 58 knots. So very good low level to upper air shear going on here. I want to take a look again at these storms here. Okay. All right. So continuing to look at the environment, we got steep lapse rates in the area. So these steep lapse rates will help with significant significant updraft speed necessary for things like large hail and stuff like that to develop. So that's something that will be helping with severe hail potential. Dew points today have been they have been it's been the highest we've had so far this year, upper 60s, mid to upper 60s dew points. So it's feeling pretty humid out here today across the area, and we'll continue to feel that way until we get past probably 6 to 7. Never mind. I want to say 8 to 9. It's kind of what we're looking at here. So now let's look at tornado potential for this evening. Tornado potential is expected to increase by probably, I want to say 6 to 7 p.m. this evening, as the low-level jet will kind of mix in with the low-level jet is, if you're wondering, is associated with the 850 millibar level. So the combination of the 850 millibar level with the upper dynamics of the 500 millibar jet streak will help with turning with height, which is what we see here with the photographs. We got some nice curvature here. This will help with tornadic development here this evening. If you bring up the significant tornado parameter, we definitely see that it's going to peak here within the next couple of hours, probably 1 to 2 hours from now. But you see some areas you got like 6 to 7, which is really high for significant tornado parameter. And these areas really suggest as not a official indicator for severe weather or when it comes to tornadoes, but it can help you a nice toolkit for that. So now let's look at some surface data, not surface data. Let's look at visible satellite. We can actually give you an idea of what's really going on out there right now. Let's do this. Yeah, so here it is. Here's our main line of storms. You can see you got the moisture channel feeding in the storm right here. Okay, gotta pause it right there. And you can see, yeah, your cumulus field right here. You got your horizontal convective rolls developing here, which are basically streaks of cumulus clouds that develop during severe environments. They usually are a indication that you got almost like a capping inversion in place, enough for cumulus clouds to develop, but they're not likely to develop into full-blown thunderstorms. So, so my idea for the best chance for seeing more supercellular type thunderstorms to tornado-like thunderstorms would probably be kind of in this area right here. I can label that right now. So my general idea for how about this? Let's say my general idea for best chance for supercells would be kind of down in here, but given they're moving more of a northeast projection, they would probably also include a little bit farther in this direction as well. So definitely something we want to continue to watch here as we head into the evening hours again. And so yeah, so we can actually pick out a lot of things about this. So we can actually pick out it's a little hard to see, but you can kind of see some overshooting tops here, and those can be indications that you got pretty intense updrafts. That can also be an indication that you got large hail beginning to develop or even is occurring. So that's kind of what we're seeing right now. Not really necessarily hail, but they're definitely yeah, 1 inch to 1 inch hail. So not really large as what they're seeing at 3 inches, but definitely these will continue to strengthen as they continue their eastward extent and stuff like that. So so yeah, just want to continue to monitor these storms as we head into the evening hours, and I don't really know what else to go over now. So I guess thank you for tuning on. For the people who have tuned in, I know it's a little bit shorter, and and I didn't really go in too much deeply into the. I didn't go too deep into the explanation of the setup here today, but I just wanted to give kind of a general idea of what could be happening here today. But just general idea, we got a potential outbreak for severe thunderstorms that could and definitely develop here this late afternoon and evening. So thank you for joining in, and I don't really have too much else to say besides that. Just continue to look out for these storms this evening, especially ones kind of a little bit to the farther south, southern metro area, as we definitely see those chances for tornadoes to be at their highest by probably around 5 to 6 p.m. Even though right now, if you're looking at radar, it doesn't look too interesting quite yet, but yeah, you can see this little gap in the middle here. Definitely want to. Oh, we got a tornado warning down here. You definitely want to. Yeah, you might be like, oh, there's nothing here. We're gonna be fine. Well, no, there can be embedded stuff that will just develop out of nowhere. That has happened many times. So anyway, so thank you for tuning in. I hope you found this helpful. Just kind of going over the things that are expected here today. So yeah, thank you for joining in, and I think this might conclude our our little stream here. So I'm actually going to be heading outside and just checking out what's going on outside, and I'll try to see if I can keep you guys posted on my channel. I'll put out maybe a short or two, kind of just showing what the environment's looking like outside in my area. So thank you for watching, everyone, and have a good rest of your night, and stay safe during this severe outbreak tonight. All right, goodbye.